Are the denominators the same? No. Here we have 2/3. And that is 1/6. Well, those pieces are not the same size. So we're going to have to find a number, a denominator, where these pieces can agree. They can be the same. We need to make them the smaller piece. You can't make a small piece bigger. But if you cut a bigger piece, it could be smaller. So we're going to need to work with the larger numeral, which is, ironically, the smaller piece. Is there a way that we could cut our thirds and make them this size? Well, let's see. If we put a 1/6 on that and another one here, oh yes, that works. So 2/6 is the same as 1/3. So I'm going to guess that this will fit over the other piece perfectly as well. So our equivalent fractions in this case, instead of calling our fraction 2/3, we could call it by its equivalent 4/6. As soon as we got that, it matches perfectly to the other number 1/6 that we have, so we'll just drag this over. We won't have to change anything here. We could have gotten this mathematically, I showed you with the pictures, but mathematically, if you multiply the 2 times 2, you would get 4. And if you use 2 times 3, you would get 6. So this is the mathematical way of doing it, and this is the picture of it. Now our addition problem has common denominators. See, before we could keep the common denominators, we had to make them common. So this step right here was done before we could start our actual steps for adding fractions. Of course, the subtraction are similar rules. So we finished off this making a common denominator, and now we're going to follow the normal steps for adding fractions, which says add the numerators. So 4 plus 1 is 5, and keep the denominator, which is 6. That's the size of the piece. And our picture shows us that we really do have 5/6. 1, 2, 3, 4,